Hello, everyone. Welcome to the second day of our HiveMind Summit conference that is focused on AI productivity. And we are a part of a bigger Slack community called AI Product Hive. So if you've heard about our conference from Reddit or from some other place, feel free to check us out. We are a Slack community of technical AI professionals who are interested in AI and how it can be applied to various aspects of our day-to-day jobs, activities, and other stuff. So you can find it interesting. Also, if you really like this format of short 1 hour calls that you can tune in during the breakfast, for example, or like just listen as a podcast on the background. We are running those calls on a regular basis in our community. We've had more than 30 of those. So yeah, join us on Slack and we'll have some other upcoming calls sometime later after the conference. So yeah, please be aware that the call will be recorded. We will send the recordings to your email after the conference is over. And yeah, please keep muted on Zoom if you don't want to talk. So thank you. This is the agenda for the upcoming days of our conference. So today we'll discuss how you can evaluate RAG systems. This is an extremely crucial thing if you want to add AI to your existing application or improve your documentation with AI, something like that. And after that, Thiago will share Meta's segment anything model, extremely cool model for image segmentation. Tomorrow we will have a talk about Anthropic Console and how you can use that as a product manager to write more efficient prompts and a structured workflow for vibe coding. Extremely popular thing right now regarding AI coding tools. On Thursday, we will have an open microphone discussion to talk about what approaches we take, what we are doing in our day-to-day lives. And on Friday, we will have talk about enterprise level AI orchestration and introduction to BAI from Sandy, who's working at IBM. So today's speakers are Tanvi and Thiago. Tanvi will share success metrics and how you can evaluate RAG systems and AI agents. And Thiago will tell us about Meta's new segment anything model. So please meet Tanvi. She's the lead product manager at Scrat Automation, data scientist turned product manager, and hobbyist chess player, photographer, and avid esports enjoyer. So Tanvi, please take the stage and let's get started. I'll stop sharing my screen. Yeah.
Thank you, Max. Happy to take over screen share now. What a great introduction, by the way. I loved hearing that. Um, just let me know once you're able to see it, please.
Yeah, we can.
Okay, great. So hello everybody. Welcome to AIPH, as Max already has mentioned. We are today talking about a topic that at least we have struggled with quite a bit in the past few years, have a lot of learnings from, and excited to share this with the group today. This is on success metrics, evaluating any RAG systems or any AI agents that you might be using, either in your day-to-day life or specifically um, as a feature in your workplace, and as you get to improve it. Um, so just few things to know that after this you will walk away with very clear examples of what to measure, why it matters, some common mistakes that we made before and maybe that you can avoid in the future, um, some very easy way to start testing, and super excited for this topic because uh, we didn't plan this, but tomorrow's conversation is actually going to be an extension to this. And then some tools that I use to make testing much faster and much better. A little bit about me. Before we get started, I've been in the AI/ML field for over 7 years now, um, at all of these companies. Previously, I used to be a data scientist, so having that context has luckily really helped out in my product journey, developing AI features and products at Scrut, where I'm at now. The uh, our AI product suite is called Scrut Teammates. So that is what I will be hinging most of my learnings on today. And I do talk to ChatGPT quite a lot. It's a running joke now. It's on my home screen, constantly open. So I think I have lots to share here. Um, just to talk, just to lay the context, evaluating agents, evaluating RAG is really, really hard. Everybody wants to launch it. Very few can tell if it is actually working. We have a lot of ways to test APIs, UI. We have automated ways, Selenium, web browsers, all of those things. But with AI agents, very often it so happens that at least the first version, you are shipping based on vibes or a general understanding of what you think is correct. Um, is it accurate? Is it helpful, on brand, grounded? It's really hard to tell unless you are actually analyzing the response out of the RAG system. Um, it is, of course, even harder to do when you try to evaluate after the complaints start coming in, because then there are just way too many things to fix, and those mistakes end up getting scaled. Uncertainty is an inherent property of LLMs, so it's really hard to get around it. But the most we can do is at least have some control around what we are giving out. So the case study is, of course, Scrut Teammates, as I was mentioning, the product that I have worked on for the past few years at Scrut. What this is a bunch of features, but the primary one we will discuss today is a questionnaire autofill feature. It's a standard RAG pipeline where we read through security documents that our users upload, and we help them answer security questionnaires, which businesses very commonly get. They spend multiple people hours, uh, hundreds of people hours actually, throughout the year trying to fill these questionnaires, so very important from a business standpoint. And since these are going to answer questions about your security program, like what encryption algorithm you use, where do you store your data, which regions it is stored in, it is accuracy is of a lot of importance for us. Um, this is just to set the stage that for every application, priorities might differ. For example, I was talking to a, a product manager at character.ai the other day, and that is a platform where you are able to chat with various personas of people. So in that case, privacy and safety is really important. You don't want that persona to tell you something dangerous or something that uh, won't fly in a normal setting. Um, so this is just to say that uh, the goal of your use case should also matters a lot in what you are evaluating, and we will of course talk about that a bit more. Mine, of course, are grounded in this Scrut Teammates case study. So right off the bat, I will take some time to admit our mistakes early on. We were popularly one of those folks who went on the pretty good standard of releases. It's not really evaluation, it's just going on vibes. Um, Even when we went deep into the answer, we would realize that whatever we were checking for, there was a uh, like kind of a gotcha moment to it. Like if it answered, maybe it wasn't enough. If it linked the correct sources, maybe it was the wrong link. If it referred to a particular document, which means the answer was grounded, it didn't mean that it was relevant. If somebody approved it, like on the product UI, if they actually used that answer that was given, then maybe they did that after rewriting it completely. So we really needed a structured and testable approach that could work at scale. It is really important to break it down and talking about the goal that your product has. That should ideally be the North Star that's driving each of these. So, for example, for us, it meant going layer by layer. Firstly, when the question itself is coming in, did the agent understand the question correctly? Um, Security jargon and infosec jargon can be really hard for humans to understand, let alone LLMs to understand. Actually, a really interesting thing that happened here was, um at least in the very beginning, our LLM would get confused between names of companies and security terms because we have customers whose names are like Bright Security and Scrut. At least it's easy to tell that it's a name of a company. It doesn't mean anything security wise. But that distinction, for example, was a really interesting one that we had to make. So just being able to understand the question and what it is asking for was a bigger challenge than we had anticipated. Um, Second layer was the routing layer. The way we had structured our agents was that one of the agents goes through the documents and picks an answer. But if the question is asking you to attach a document, then another agent will also go in and actually attach the document. Um, so making sure that uh, either one, both, or neither agent was called in the correct situations was again an important layer to consider when we were evaluating. Now, going even one level deeper, if the correct agent was called, if the question was also understood correctly, then was the correct document referred to? Um, Over here, the challenges took much longer to solve just because of the amount of documentation we would have to go through. You really have to know, at least in the beginning stages, what is there in what documents. Really important to look at your data physically, manually, and also to ensure. And over here, like a few product skills also come into play where you have to make sure that you're working with your customers to make them understand that if they don't maintain up to date documentation, we won't be able to give up to date answers. So, having smart features in the product, uh, making that communication very clear is also, again, a very important thing. Now imagine we are at layer three, we have the correct document referred to as well. Um, we have gotten an answer out of the system. Now, the answering piece for our context, at least, meant that it has to be accurate, complete, and helpful to whoever is reading the answer. Um, it shouldn't make up things on the go, of course. It should not hallucinate. It should be complete. It should not miss any important information. We are referring to multiple documents at the same time. So, making sure that all of that information is correctly captured in that one answer is really important. And answering it in a professional, security way is also another important point. Um, we, of course, made the prompt that started with, like, you are a security expert and all of those things, but it doesn't stop there. A lot of times when it would see answers which were kind of related, but not really, it would go back to its old ways with the long answers and all of those things. So, prompt engineering, looking at data again, really important here, and of course, giving examples. Um, Finally, the actual outcome that the user was looking for when they used this on our product interface. There were a lot of UX measures here. For example, on our UI at least, we have the usual thumbs up, thumbs downs. We have the actual acceptance of the answer. So, uh, product metrics also help in really tracking whether overall this feature helped the user um, get to what they wanted to get for, is again very important. So, of course, didn't have enough time to break these down even further, but there is a lot more going on under the layers. But yeah, this breakdown of the system layer by layer really helped us isolate the problems if one occurred. Um, there is lot that's going on in a RAG system. It's not just a blanket system that you put into play, and if there's an error, you're able to find its own. So this breakdown is very important to do.
Yeah.
It
Tan,
helps us.
Tanvi, sorry for interrupting. We may
Mm.
run a bit short on time. So yeah, if you can
Oh,
go through the slides a bit quicker and jump to the
sure,
demo, it'd be great.
sure, sure.
Thank you.
Um, so, I don't have a slide, like a working demo, but I was just going to do it on the teammate space.
Uh-huh.
Um,
Okay.
I'll just need few more minutes to wrap it up.
Uh-huh. Yeah.
So, yeah, after breaking it down, we were able to catch very important mistakes, wrong responses, hallucinated reasoning, tone mismatches. We were able to catch them really early on, and we were also able to articulate what that meant. Um, Trade-offs, of course, with any system are constant. Imagine this is a nice visual, but between cost, accuracy, and latency, we are constantly, if we are optimizing for one, then the other does go down. Um, what worked for us here is starting, once we were able to articulate those issues, starting with a very scrappy prompt, get a baseline working, take like 20-30 minutes and get one evaluation prompt out of the way. Think of it like a unit test. Um, you have to really sit and uh, manually fix the outputs with the relevant stakeholders. And each correction, of course, teaches you what good means. You have to really force clarity. When you're talking to experts, ask them to break it down, to explain it to you like you're a 5-year-old, and in turn, whatever simplest language, because that will help you then translate it into the prompt that you are writing. From users, the same thing. Giving them scales of 1 to 10 usually results in more vague feedback. So, giving them very specific thumbs up, thumbs downs, asking them why, giving them a few options up front are some UX ways to force clarity as well. Scaling up, we all have heard of LLM evaluators. They are a bit dangerous to be used blindly because, again, it's one uncertainty evaluating another uncertainty. It's possible that they will reward the wrong things. So, very important to again treat that as a unit test. Make sure that it's actually doing the thing you want it to. I use a few tools listed here for this. And the Anthropic console, promise it wasn't planned, but tomorrow's talk will go deeper into that. I really enjoy using it. Here is a sneak peek. Um, you can describe the prompt in very scrappy language, and especially for a lot of us, I'm guessing, where English isn't our first language, this really helps. It's able to write it down, and it's also able to create synthetic data for you to test these, make the improvements and all of those stuff right in one platform. So that is all from me. Max, thank you for the trigger there, but hope we are on time. Let's take any questions.
Thank you very much. Yeah,
Well,
let's see.
let me ask one, and it's a question, I guess, in the form of of a comment, but with agents, I've certainly seen that we have to kind of keep them on a short leash because if you let them go off too far, it's kind of like a bowling ball down a wide alley, right? You may hit the pins or you might veer off and hit the restaurant. Um, are you finding then that if I'm hearing you correctly from your presentation that you're having to put all these guardrails on to kind of keep the ball there? How much human interaction do you end up having when you run agents then in order to try to keep the 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 agent or the set of agents on track? Is that a significant part of the process during, I'll say, production usage versus when you're trying to put the system together initially?
During production usage, now when we spent a lot more time in the POC stage, when we got into production, it was comparatively lesser, but still a lot more than I had anticipated initially. It's kind of like the error logs is the most direct comparison to this. You get a lot of error logs, but you still have to diagnose those to know
Hmm.
what exactly went wrong. So these evaluators, any automatic signals that you can maintain are always a, hey, this is going wrong, but not this is the exact thing you need to fix. So RCA is still very important to do, and we still do end up spending time uh, going into the weeds of it. And talking about the agents, they do tend to go haywire. We have severely limited the amount of tools that they can access. For example, in the questionnaires case, it was only the search. Um, so yeah, we are very careful there as well, so as to not
Hmm.
let it access many tools. We've
Sure.
also simplified them a lot. We don't let it do any kind of data manipulation, anything like that. So yeah, that's of course in place.
Good. Let me ask a question from one of the other participants.
Mhm.
Are you guys fine-tuning models when you detect misalignment at the response retrieval tool calling level? What are the actionable steps besides updating prompts with do not, like do not do this, do not do that?
So, first question, are we fine-tuning models? No, we use all of the models out of the box. They've been getting really better over the years. They've been getting much cheaper over the years as well. They've been getting cheaper at like 10x per year, or something like that is the actual number. But misalignment, other than updating prompts, if it is a prompt issue, then it is a prompt issue. What we have done is we have a very limited 50 question release qualification list that we have curated with a lot of effort. Um, uh, any prompt update, if those 50 questions it's not answering, it doesn't go ahead. So that's unfortunately prompt tuning is one of the things. There are also several other ways though, other than the do not. There's ways to give more examples. Maybe some of the examples you gave could be changed, some could be entered. Um, and oftentimes there's uh, uh, at the retrieval stage, at least, there could be issues with your data as well. So looking at your data, making sure that it actually had the correct information, that also really helps. Um,
Mhm.
it also depends on what the do not is for. Uh, for example, for us, it ended up happening that we were giving the LLM way too much context to get the correct information out of. So it could also be an issue with some of the other variables like a top K or a temperature, which could have to be tuned to change the answer. So it really depends on what the do not is basically.
Sure. Yeah. No, you just want to say, do what I say, do what I'm thinking in my head, please. That would be the.
Yes.
Um, so there was a question, and I'm just going to summarize it. Are you all using open source tooling for this, or you're finding yourself have to do a lot of proprietary development for this? Are you able, or are you able to rely on open source frameworks like LangChain and Llama Index and things like that?
So we have been uh, fairly on the Lang dash, all
Oh,
of
yeah.
these products. So LangChain, Langsmith, LangGraph, all of those
Mhm.
we've been using. We so far it's been great, but uh, I do hear from our developers that they are having to increase the release cycles because there's not enough flexibility and they end up having to build certain things on their own. But
Mm.
that's on the developer side. From a PM side, Langsmith has been pretty good. We also use another product to make sure the query is routed to the most available or the LLM which is going to give the most accuracy. It's a product called Portkey. So that's also something that goes on in the background.
Okay. Oh, very good. I'll take one more here. This
Mhm.
says from Naveed, I've developed an agentic RAG where I made multi-RAG collection. Each of them are specific purpose, along with two other agents. It's working as expected, but I don't have the experience to integrate with the website or build a custom. So could you share with me a roadmap of certain resources for how to integrate in agentic RAG into a site? That's kind of a big question, and it's probably a longer one that would take to answer. Um, but I think what he's really asking is how do you integrate in agentic RAG into a website? And that's it's a good question. It's not not an obvious one sometimes.
Yeah, yeah. For us personally, we are an AWS shop, so everything, our databases, our even indexing vector databases, uh, the re-rankers, all of those things are on AWS.
Hmm.
Um, so we primarily use that. However, there are several services that you can use if it is a personal project as well. Of course, as Max said, we can keep it as an open question on Slack. Curious to know what
Yeah.
everybody else also
Yeah.
does for this.
Well, thanks, Tanvi. I'm going to jump in because I know Max was taking care of some things on the chat. We're tag teaming today, but thank you so much for your talk, taking the time to speak with us. Please take this as a virtual uh, from everybody, and thanks again for that. It was really timely, especially with agents these days. We have to be careful about you
Yeah.
know they sound believable many times. Is it correct?
Yeah, no, for sure. Thank you for having me.
Thank you.
Yeah, thank you very much. So yeah, up to our next guest, Thiago. So he's a director of AI ML at Panorama Design, leads R&D initiatives in companies and consulting firms, and both a seasoned AI leader and a professor. So Thiago, please take the stage.
Thank you for the introduction, Matt. I'll share my screen right now. Okay, everyone can see it, right?
Yes.
Yeah.
Okay, great. So today I'm going to talk a little bit more about SAM, segment anything model 2. That's from Meta. I'll talk more a little bit about what's the use, why you should know about this model, and beyond a little bit of the clickbait that was basically everything on the internet about this model was kind of clickbaity. So today I'm going to try to put take show from an angle that's really useful for computer vision shops and developers and applications. And just a quick introduction. So my name is Thiago. I'm director of AI ML at Panorama. I've been working with Matt for quite a few years right now. I mainly work on computer vision and natural language processing uh, before Gen AI and after Gen AI. So that's different applications, and I'll make some parallels today here, and hope to make sense of all of these technologies too. So starting out, what can I do with this model? So basically at the right here, we got a segmented image. That is, someone went ahead and like draw all these little polygons and selected and did this work all manually. Why is that? Because some computer vision applications, some CV applications need that type of information to be able to make predictions, right? So here we can think about self-driving cars. This is the first example that comes to mind. We can talk about agriculture, medical. Medical is really big with segmentation. And actually, this model is a foundational model. And I'll talk a little bit more about what a foundational model is. But this model is a foundational model for creating segmentations really quickly with minimal effort. So this is huge because probably 80% of the whole machine learning work slash data work is data preparation, right? So you need to prepare your data, you need to label your data, and Sam is really good at doing that and reducing human effort in order to create data sets for other models to use and be trained on. It's also great for like removing background. And if you have like, oh, I use a lot of ChatGPT to analyze images and sometimes it's not really good. So you can use SAM to actually extract, make a mask, extract the object that you want to focus on, and then put that object on ChatGPT or Gemini or Claude or whatever. And you can do that as well. So basically, here's the angle from a computer vision shop. Like we use SAM to create better data sets faster and with less human effort. But now you might be wondering, okay, so we can send images to like ChatGPT. Why isn't that enough? Why do I need to use SAM? So basically, VLM, visual language models. They used to be called multimodal language models, but they are language models that can actually see images, watch videos, listen to audio, and read text, right? They are really good at doing a lot of things, but from my experience, specialization wins. So domain-specific tasks like weed versus crop, tumor versus healthy tissue, and so on, they require specific models that will run faster, will be cheaper, and you will have more control over it. Also, data bottleneck training, and we created some of the largest Portuguese data sets for visual language models and chain of thought data sets in Portuguese, right? And we know it's really difficult to generate those, and to make the fine-tuning also is not trivial, and it can be quite expensive. So the main point here is, okay, we have those models, but it might be better to use specific models for specific tasks. It will be cheaper, probably, and it will be faster, and we will have more control. And just a little example here on the right, this drone picture that's kind of out of context. It's actually a picture that I'm going to do some samples on it after on the demo. I'll be speaking a little bit more on this presentation, but then we'll jump into the Colab notebook. And here I asked for the two main visual models like ChatGPT and Gemini to actually select the houses of this picture. So we can all see some roofs here, right? So here are the results. So ChatGPT 4.0, and this was generated like this week. So it's basically the main model, the paid model. It generated some bounding boxes here that are not like segmented houses, right? And the 2.5 Gemini Flash generated this kind of annotation that also is really wrong, right? It kind of got it some things right, but it looks like it's not doing anything, right? So we will see later in the demo how SAM works with this and how SAM work with prompts as well. So what is segment anything? Basically, it's a foundational model trained on more than 1 billion masks, and you don't need a GPU farm to run it. So it's pretty, I'll just put the video here. It's pretty easy to run. You can actually run all the demos here that I'll provide the Colab notebook on the free T4 that Google provides. And it matters because it's a general knowledge tool to actually help you understand the image pixel by pixel, and you can steer with simple prompts, okay? So here is the result of doing the house segmentation with a prompt with SAM. Much better, right? So we'll take a closer look on how we can do that after some slides. I'll just run through some basic explanation here, not going to get so deep into the technical part, but just to get a good understanding on how SAM works, what are those prompts, and what can we do with it, right? So for all these demos, we are actually using SAM 2, some minor upgrades, efficiency upgrades, improved text to mask, and some core benefits. So right now you can actually use SAM 2.1, is already released. So basically it's the best model to get started on. And of course, it's free. You don't have to pay an API. You can run it on the free Google Colab, the Google tool for running Python, with the T4 GPU, right? So just entering a little bit and doing a parallel between foundation models and specific models. So on the left here, we got the natural language processing. So basically text work before GenAI, right? So we would have to train specific embeddings. We would require thousands of labeled sentences. So this is spam, this is not spam, something like that for each task. And we would need to build a new model for each case. Jumping to the CV, to the computer vision side, we would need to maybe use some pre-trained ImageNet, then fine-tune UNet or YOLO or something like that for a new task. It would require thousands of images labeled, so that is actually really tricky to do. Then that's really where most of the human effort goes, or doing it by hand, or doing it with some models and trying to make those models work a little bit better so that the human work is a little bit reduced. And each new domain is starting over, okay? So this was before having foundation models. After foundation models, so in the left here, we got the natural language processing, and we just prompt, right? Translate this, summarize that, like the previous talk here, don't do this, do not do that, right? Same kind of stuff, but they are multitask. And of course, we can fine tune and we can create a specialized version on it on top of a data set. And that could be also like a few shot prompting if you don't want to fine tune. That's for another time. Anyway, but you can deploy the same model for many applications, right? You can use the same model. You just need to work a little bit on the prompting, on all the a little bit is an overstatement, right? But on the computer vision side, with a foundational model like SAM, you can prompt SAM to generate masks, and you can prompt with text. We will see that, but you can also prompt with points, with bounding boxes, and that makes life easier, right? For developers, for the company, for everyone involved in the project. We just need to do some cleanup, right? And basically 20% of the full effort that used to be. So that's a metric that we kind of got after deploying and using it. And you can actually fine-tune a lightweight domain-specific segmentation model with using those masks generated by SAM. Okay, so just trying to wrap up, make a summary. Like we use SAM to generate the label to then train the specific model. So it's a pre-training exercise using SAM, but that's actually all the time. All the machine learning computer vision time is basically used doing that pre-training. Like training, it's like you just wait and it's training, right? But you need to supply samples, you need to supply labels, and that's the hard part, right? And of course, you can actually deploy on a small, optimized computer vision network on the edge or cloud, whatever. You don't have to actually deploy SAM. SAM is a back office kind of work, right? So here's the core strategy. We gather raw images. You can be drone shots, you can be MRI stacks, microscopy. You create some kind of automated prompt generation. You can use like another model, a simple model, some really basic YOLOs, really basic faster name, something like that. Then you generate the masks with SAM, okay? And then do some manual cleaning and then train the model. So basically that's the beforehand job, right? Is basically creating labels and data sets. So under the hood here, I'm going to go really quickly because I want to get to the demo, right? But we have a vision transformer backbone. So we are using attention here. We are using all the attention is all you need kind of work. We use an encoder. So we map that prompt being bounding boxes or points or text into vector space, right? We use a mask decoder that will fuse images and features, and we also do multi-scale feature fusion. Okay, a lot of technical terms, but basically it's using a lot of work that's being used on language models in order to get that flexibility of a foundation model, okay? And here we're going to talk a little bit more about prompt types and their roles. So we have points, boxes, masks, and texts. So what is it? When to use it? So points, single points, and when we need to fine-grain control on ambiguous regions. So we have medical imaging, usually really ambiguous, right? Boxes, we have the usual bounding boxes, and when to use it, quick localization, or basically image detection, and that's it. Masks, we can actually use existing masks and do refinement on it. And text, I believe that's the best part, is natural language descriptions. Like, so I have that image, I want to find all the houses, I just write house and I run the model. That's how we do it. That's the basic prompt that we are all used to it. But this is the last thing that's actually not really supported by SAM, but it can be used with SAM, right? This is getting a little bit deeper, but I think I'll just jump this to get to the demo, okay? But this is a little bit deeper of positive and negatives of each type of masks. So bear in mind, it has some positives, it has some negatives, and also for the masks, right? And here, how we deal with ambiguity with SAM, right? Because it's a foundation model, it will segment anything. So how it deals with it, basically returns everything that's found, everything that is on the image. So that's where the human refinement can be handy, right? And now we will jump to the demo. I have a few notebooks here. I think you all can see that. And I was hoping to like run the code, but I think that we are a little short on time. So I'll just show the code, and this will be available for you to run for free on Google Colab. Okay. So after the talk, if you want to run, that's all you need to do. So basically we have some parts here. I'll jump stall because we just basically install segment anything repository. It's open source. You can clone it. You can run on your machine. Here will be all the comments. We'll get some test images. So we will check out trees, plants, and medical. That's what we have today. Do some importing. So after installing, basically, we will import all the basic computer vision good stuff and the SAM, right? So we have the builder of the model, the image predictor, and the automatic mask generator. So we can prompt, but we can also automatically generate masks. from SAM, and that can actually be really helpful. Here is some CUDA stuff. So who works with computer vision knows we always have some CUDA hacks / configs on our code. But let's get to the part of downloading. So it's a model. We need to have the trained model, right? And SAM actually has a lot of different checkpoints. So you can run here, you can just copy and paste this, but you can actually use different checkpoints. So what are those checkpoints? Those checkpoints are like different models, the same model, but different types of accuracy. So we have the tiny one, the small, the medium, and the large. So here I'm using the large. You can also use the large on Google Colab for free. But if your application requires more speed, then you might want to upgrade your hardware or use a tiny version of the model. That's up to you, right? Here we just build the model and that's it. Now we can do some masking, right? So to get started, we can do some automatic masks. So I'll just run really quick to the code, right? So we will just instantiate that, run, actually read the image and generate the mask. So this is the result that SAM provides. So it's a segmentation, it's an object, an array of objects actually, segmentation, the area, the bounding box, the predicted, the coordinates, the stability, and the crop, right? That doesn't mean a lot to us, but we can actually plot that on the screen, and we will see something like that. So we have the source image. This is a plant field of some kind of disease, and this is automatically what SAM masked and actually brought in this type of language, right? It actually trying to represent all of this. So it grabbed a lot of similar points here and use it on the same class, but SAM here does not cares much about classes. It's only about segmentation. And some other points are a little bit different. Of course, this is the automatic. So if we just jump back here, I'm just like, hey, generate this. I'm not actually passing any parameter, right? But we can pass parameters. We can so here are the masks, the main masks that it generated. So different types of classes. And we can actually generate with a lot of parameters. So here you can fine tune it as much as you want to get a result that's more similar to this, right? So we have a lot of different classes and a lot of different types of points, right? And this is basically just messing around with these parameters. They are all open source, so you can actually read through them and get an automatic mask based out of them, right? So this is the automatic generation. So from here, you can actually get that mask and create a data sample that you can go ahead and train your model. And I didn't have to click around and draw and do that type of stuff that we usually do, right? The next step is prompting with boxes. So we can actually prompt with some boxes. So here we got a medical image, and I can actually plot a widget here where I can draw some boxes, right? I can actually mark where, this is a little bit ugly, but where do I want to segment? And after submitting that, I can actually grab, so this image on the left was what I actually selected, and this on the right is the segmented one. So what's the difference? The boxes are really easy to do. I can actually pre-train a YOLO model or a image detection model really quickly to do that, but I cannot do the same thing to do this, right? So this could be used in partnership with another model to generate some segmentations for me. And also we can use points, right? So the same idea goes for instead of using boxes, I can just click on top of the points, and then I can generate something like this, right? So we have the full masks here. Okay. What about text? So these are all good, great. I can do models to actually help me do that. I can actually use the auto mask. Everything is great, but I want text. So for text, I have another notebook here that we'll be using LangSem. That actually, I said earlier that SEM doesn't care about classes. It doesn't. So what is basically some libraries did, right? Some open source libraries, they actually grounded SEM. So it's a technical term. To ground SEM is to actually give SEM a class, give some that knowledge of existing classes, like existing classes on a data set, right? So you can actually use those two models together. And this is actually what LangSem does. LangSem anything. It uses SEM and it uses another model to actually ground two classes. And what can I do when I ground SEM to use classes? I can actually prompt SEM with text. So after installing, importing, I can actually run some test masks, right? And here I'm opening up this image, right? The image from the slide deck. And I'm texting like a real prompt engineer, crops, just that, nothing else, right? And I can ask, like, predict this. And it predicted one mask and actually predict all of this, right? So this, imagine if you had to do something like this by hand, right? So this is really, really awesome. Of course, this is just an example, but this is really awesome and it can save a ton of work. And just reminding us of the prompt that we shared on the slide deck. So another complicated prompt that needs a team of prompt engineers, right? House, just that. And we ask for LangSem to predict that. The result is always a bounding box. The labels here we have the scores, we have the masks, and we have the houses here. So it's also really well defined. And bear in mind, this is not like fine-tuned on anything. So imagine, and this is one application that is really useful, to actually grab this type of application and just fine-tune it, just direct a little bit more into our medical domain, or like a drone shot here for agriculture, for our ag tech domain, right? So it's really powerful and can really help us save some time, right? The better part of machine learning is not like the cool hype training, hyperparameter tuning. That's stuff for machine learning researchers, right? That create papers and create networks. For most work is just basically using what's available, what are the networks that are available, the models, the pre-trained models, but working on the data, right? And this is an awesome tool to work with our data in order to create better machine learning models. Just to wrap things up here, I think that we will have some moments if there's any question.
We will have some time.
Going back to my presentation here, so technical considerations, we will have, of course, prompt engineering, quality in, quality out. Those samples that I show are just samples, right? For application, you need to actually do some prompt engineering, maybe some cheaper models, some automation, something like that to scale. Here, domain shift, right? So always fine-tune your own model on those outputs. It's really useful to do that. And compute costs. So if we run really, like this is an approach that even Tesla does. So they have or they used to have a really, really powerful computer to do like pre-training annotations and labeling. And on the cores, the model was actually much more lightweight. So we can steal that out of Andrew Karpati's book, and you can use that as well, like run the SAM2 large fine-tuned on your own infrastructure, right? To actually get the best segmentation possible, and then train lightweight models to then get really fast inference times on the edge. So this is my email, and these are the collab demos. I believe that Max will share those because I'm not sure if anyone wants to like, or you can just like take a screenshot and show to like some model and it will do OCR for you, but it's not a really friendly link. And hope I have contributed something, and really glad to be invited to talk here on this event. So thanks, and I think that we can take
Yeah,
some questions now.
thanks, Thiago. That was fantastic.
Thank you,
We do
Matt.
have some questions from the community. Um, One of them from Joseph is, how does it scale to video? I'm guessing it has to go frame by frame.
Yeah, so this is an awesome question because Sam is actually advertised as video, a video segmentation model to do some kind of animation and stuff, but basically it's the same thing, right? You just run it frame by frame. The thing is that for most computer vision applications, they don't care, at least the ones that need segmentation, they usually don't use, like you don't use segmentation for doing video action recognition or something like that. There are other ways to do that. Of course, you can do segmentation for action recognition, but I haven't touched on this subject because we have worked on some projects, and basically for action recognition, action localization, you usually don't want to segment. You usually want to apply some other techniques, but it works on video and it works really well. So it's frame by frame.
All right, very cool. The next question, also from Joseph, have they layered on outline maps with this pixel map to figure out when something is partially obfuscated?
Yeah, you have like object occlusion is a really large topic of research and work. You have like SAM as a foundation model doesn't touch on that, but at least as far as I know, but you have a lot of combining libraries that actually do the prediction of occlusion and do some kind of prediction of the whole object, the whole segmented object. But I haven't actually used for occlusion, because basically occlusion happens a lot on the real world, like security cameras and stuff like that. But for the domains that I use SAM, that are medical and ag tech, it doesn't happen so often. But I would believe that there are some libraries that actually do prediction of occluded objects and actually run the full mask to get the return.
All right, very good. One more question as we wrap up, which was my question actually. In contrast to training a generic LLM, how much effort is required to create a grounded model that would adjoin SAM so I could use text prompts to identify specific targets in images or specific objects in images?
Yeah, to create it would probably require some work, but to use something like LambSam and to actually fine tune it or specify on your own domain, that's a much easier job, right? Because we already have the connection between the embeddings, and we just need to actually work on the fine tuning and generating data for that. So for creating from scratch, I'm not sure if that's so easy, but what we usually do is to actually run it on a downstream task.
All right, well, that was all the questions.
Great.
Thank you very much, Thiago. That was fantastic. Really well done.
Thank
Max,
you. Thank you.
I'll give it back to you.
Yep. Thank you very much for your talks, Tanvi and Thiago. So those are the locations that people joined from, overwhelmingly Brazil. But yeah, I hope we'll have some other contestants. And yeah, people are joining from across the world, which is extremely cool to see. So thank you everyone for joining our today's talk. So especially thank you to our speakers who shared their insights and community members who asked the questions. So we will be extremely happy to see you tomorrow when we will discuss how you can improve your prompt writing skills using AI so that for example, in Thiago's demo, you will be able to modify the code and add something in addition to just trees or buildings. So we will see how you can improve your prompt engineering skills, which is absolutely a must-have skill in our day and age. And the second topic will be about probably even more important skill is to how to write code using AI and how to do this in a more structured way. So there will be even a framework that can be used to achieve that. So thank you everyone for joining our call. See you tomorrow. And don't forget that if you have any additional questions, you can message our speakers and guests at our Slack community, aiproducthive.com. So see you everyone, and thank you for joining.
Thank you, Max.
Bye-bye.
Bye.
Thank you. Bye-bye.